viewers today. My name is Arun, and you have started watching the AI with Arun Show. In this episode, we have a deep dive on DeepSeek. So, DeepSeek, as you're all aware, has taken the world by storm. In order to understand the story behind the why and the how it shot into limelight, we are joined by AI expert Shravan. Shravan is an accomplished AI architect at Vayavya Labs with over 15 years of rich experience in AI. He's a master's from the Indian Institute of Science, IISc, in Computer Science and Automation Department. He is a distinguished professional with 4 US patents to his name. He is currently pioneering AI, computer vision, and large language models, LLMs, that enhance engineering productivity. At Vayavya Labs, he is at the forefront of developing innovative technologies, including a multi-agent LLM tool that automates coding guidelines, compliance, and explores generative AI's potential in software development. Beyond his technical expertise, Shravan is also a published author. He has co-authored the book Practical Mathematics for AI and Deep Learning, which is a comprehensive guide that provides insights into AI methodologies and mathematical foundations for AI systems. So, Shravan, a very warm welcome to our show.
Thank you, Arun. It's been a lovely introduction.
Yeah, awesome. So, Shravan, let's
Thank
jump in. Yeah, so Shravan, let's jump in. Now, let's talk about DeepSeek R1. Right. So talk to our viewers about, why has this suddenly become in the news? Why is everybody talking about DeepSeek R1 now?
So when you talk of LLM models, first came the completion models, then came the chat models. Right now, it is an era of reasoning models. And this R1 is a reasoning model. Now, what is the difference between these is completion models. Like you give a partial sentence, it completes the sentence. So it's a completion models. And in fact, you ask a question and based on the completion of the question, it will reply the answer. Now coming to the chat models, there is a question asked, there is a reply. And another question is asked based on the previous reply. So there is a conversation that goes on with the LLM model. And those LLM models are called as chat models. So chat models can see the previous conversations between its replies and ask questions, and then it will further fine tune its reply. Then now it's an era of reasoning models. What is with the reasoning models is before even replying, if necessary, it will try to reason steps to reply to the answer. In fact, by using chat models, what we try to give to get the chat models a task done, we try to give it steps that it has to follow to complete the task. Whereas in the reasoning models, those steps, intermediate steps called as chain of thought, is itself generated by the reasoning models, and at the end, it's replied. If at all the reply, if the question that's asked is very simple, it replies directly. But if it is needs bit of thinking, it goes to a reasoning mode. Now, regarding the performance, the R1 models are on par with the O1 models. That's where, because R1 reasoning models are always better than chat models, and chat models are better than completion models. That's how the trend is. And why is that everyone talking of DeepSeek? Why everyone's attention is on DeepSeek is because of the cost to create the model. Even though its performance is on par with the O1 models from OpenAI, the cost is a huge factor. By using these reasoning models, they fine-tuned open source dense models like Qwen and Llama from Meta. And they showed that by fine-tuning it with the reasoning models, you can get the best out of those dense models. So these things have got everyone's attention.
No, that's good. And to your point, right, it's one of the cost part that has actually significantly gone down compared to the established model that we've seen in the market so far. So Shravan, from billions of dollars, we're now talking about, $5 or $6 million. That's what DeepSeek claims to have. So what do you think the impact will be on model development on a going forward basis?
Yeah, as you clearly explained, it's from 1 billion, we have gone to 6 million. This is a huge reduction in the cost. So many companies, where previously only the billion-dollar companies used to work on these kind of models, now the million-dollar companies will work, and just a huge opportunity for many companies to work on. And the cost will continuously go down in the same technology. Now, how does it impact the AI industry approach? Yeah, so R1 model brought into the industry certain things. For example, let me explain. In the current scenario, the LLM models development was done in 3 stages. First one was a pre-training stage. The second one was a supervised fine-tuning. And the third stage was RLHF, reinforcement learning through human feedback. 3 stages. So what did the R1 bring in is, the last 2 stages were practically compressed to one stage, and that too using pure RL without having supervised fine-tuning data. And this will be further explored by the industry. Now, the way to develop the models itself, the path itself will change. And another point is knowledge distillation. So previously, a large model used to be get trained, billions of parameters, and a smaller model the larger models is to distill the knowledge of the 2 smaller models, called as knowledge distillation. Now here, with the reasoning models, what they showed is reasoning models were used to distill the reasoning also, chain of thought, to the smaller models. And this is how the future approach would be to release the smaller models. So not only the development, even for the release of the smaller models.
Oh, interesting. So, Sean, one of the things that we keep hearing about is the mixture of experts. It's not exactly new innovation, but they have done a lot of work around it. So explain, what does a mixture of expert actually means, and what are the kind of innovations that DeepSeek has actually made in this model?
Yeah. So mixture of experts, the term says that there are many experts in each of those domains, like coding, a natural language understanding. I'm just giving an example. And you go to a certain expert based on the task at hand. The concept is the same here. The mixture of experts, called as MOE, was proposed way before the transformer architecture did come in. In fact, it was proposed by Geoffrey Hinton in 1990. And this MOE architecture was used on many models. Even it was used on LSTM language models too. And it has been used on transformer architecture before R1 came into picture. It has been, the Mistral model itself is a mixture of experts model. Now, what did R1 bring in? So before the DeepSeek R1 came in, they proposed a paper called DeepSeek MOE, which proposed a change to the MOE architecture. What did they do? They increased the number of experts by 2n. That's one thing. The second thing is, instead of selecting the experts, what they did is they fixed a certain number of experts, which will be shared across any kind of task. So the path taken to those experts is always that particular few blocks of the transformer will always be used. That has a common knowledge. Whereas in other parts, it's only based on the kind of the query that is being asked, it will get routed to that particular expert. So they brought in these 2 changes. Now, previous to this, no one thought of this. Definitely, they would have thought of this. But there are other issues associated with it. When you increase the number of experts, how will you train? How will you balance the load? How will you make sure that there is no redundancy in the data? How will you make sure the expert is really an expert rather than just passing through an agent, pass through? So all those things they were able to solve by introducing many loss functions, 3 auxiliary loss functions. And in fact, they went in much detail and proposed changes, because of which this DeepSeek MOE was able to do what it is able to do. It has become robust. And it has, in fact, certain experts are really the experts in that block by using that architecture. So this is what the DeepSeek has contributed to the industry.
That's very interesting. Obviously, the way you explained it, actually is very clear to somebody listening in about what MOE means and the impact that it made. So that's very interesting. So the other thing that they have done is about open source, right? So far, Gemini was not open source. OpenAI was also not open source anymore, right? Meta Llama is the only one that is open source, and DeepSeek is also open source, right? So what does that mean for the AI advancements going forward? and given that the cost that they have?
Yeah. So cost has when completion models was released, the cost was very high. It decreased. Then when chat models were released, the cost was high. It decreased. Then the reasoning models before DeepSeek, it was only from OpenAI, O1 models, and the cost was pretty high comparatively. And now when DeepSeek released the R1 model, then whole of this, the cost war on the reasoning models has started, because of which OpenAI was forced to release O3 mini just to match the DeepSeek's R1 cost. And it has, because of the cost of developing these reasoning models, and also uh, open source of that, the way to develop the reasoning models, because of which many companies will start to experiment with all those technologies, all those research concepts that has been proposed through these papers. And definitely many companies will get their hands on, and it's just the war has begun, right? I mean, OpenAI started with the open sourcing of models, then on its path, it has become closed now. Now, DeepSeek has started with the OpenAI models. It has got everyone's attention. Hope it doesn't follow the path of the OpenAI. In fact, if it let's say if it follows, I would say there'll be some other company disrupting this particular domain. So this is what I say: democratization of AI technology. If someone tries to hold it, I think some other company has its space to play and then disrupt it.
Yeah, no, you're right, and eventually that's where we see this going. In fact, Meta themselves were a late entrants to this, but then they caught attention because they became open source compared to, let's say, OpenAI and Google. Yeah. So Shravan, one of the things that we see is that whereas most other companies, the leading company, they use, let's say, 16,000 NVIDIA chips for training, whereas the same outcome was achieved by using 2,000 NVIDIA chips by DeepSeek. Well, what are your thoughts around that?
Yeah. So there are a lot of news going on, what kind of chips they used and all the things. But coming to a very high level is, yes, they have reduced the training cost. They have reduced the training time. In fact, the second and third stage of the LLM development that we just discussed has been purely converged to a reinforcement learning algorithm. And even while training, they brought in certain technologies like multi-token prediction, FP8 training, FP16 training. They're training on those FP16 and trying to achieve the same kind of performance. So because of all these reasons, the cost of training has come down. And because of the MOE architecture, the amount of compute that is required even for inference also, training also has come down. And because of the there are a lot of technologies, right, that has helped. It's not just one technology that has brought down the cost, and you're able to run it on 2000 NVIDIA chips. So even they introduced the multi-head latent attention. Even that has brought down the cost of training. So all this has accumulated, bringing down the cost by a major factor. I think the trend will continue in this, and particularly we listen to the news that you don't even require high-end NVIDIA graphics cards to train. I think I'm pretty convinced with that.
Okay, interesting, and that's important because so far the US was ahead in the AI race, and with China coming in with DeepSeek, and likewise there are many other companies in China who would be equally inspired to do this. How do you see the war between, or the AI war between US and China play?
Yeah. So for the past few years, we can see that the number of research papers, number of patents in AI domain from China or origin from the Chinese companies or Chinese industries or education institutions. It is already on the top. It has already, for the past few years, it is on the top, beating US. Now, whatever the ecosystem that they have built is more solid. That's where you are able to see the result of those ecosystems, right? That AI ecosystem that they have built around. And this will continue. I think now Chinese and US tech companies, the algorithms are on par. I think this will only benefit for a wider audience.
Yeah, you're right. While I think the way to articulate this is that it's not a country specific thing, right? Country A doing better than country B, but larger for humanity, it opens up so many other options and opportunities. So, Sean, that brings us to the next question. And obviously, there are, now that it is accessible, and you earlier said that there are many more people who will be open to experimenting. The $1 million companies will come up instead of the $1 billion companies. So, which industries or segments are most likely to be impacted by the new costs, now that the costs are far more lower?
Yeah. So now it has opened a Pandora box, I would say. So all the $1 million companies would want to train its own large language model. In fact, what is the best part of this reasoning models is you don't require so much of fine-tuning data. So you need to have that fine-tuning data to train the model. Now you don't even require that. The reasoning steps, the chain of thought steps that have been reasoned automatically by the reinforcement learning algorithms. So that will really change the industry who will try to use these models. And you don't even need that so much of training data. So that itself is a cost saver. So you have $1 million, few $1 million, and then you can start using this model, training this model, fine-tuning this model for your own use cases. And particularly because of this reasoning, it will really be good at coding, math, and that's what you see from the performance results also. They're really good at coding and math where you need a reasoning steps.
Yeah. So the war for reasoning is actually out on, right?
Yeah.
So Shravan, you at Vayavya Labs, right? So you are in the thick of all the development, especially around coding and development, productivity development, right, for developers. How do you see these kinds of technologies play a role in AI development strategies?
Yeah. So normally, as you see the trend, right, most of the people, I think there was a research paper saying that for what purposes did industries were using the chat models? And I think the top list was for coding. Then for coding, you need those reasons, right? Okay, why should I put this particular statement? What's the variable I should use? How the function has to be implemented? The programmer thinks through the steps and then he writes the code. If those steps are automatically generated by the reasoning models, then the reasoning models will really automate so much of the job that programmers were trying to do. It can visualize, it can analyze the issues, it can analyze the log, and reason the steps to fix the patch. Right now also it exists through using multi-agent frameworks, by using chat models, you are able to achieve it. But with the reasoning models, it will be a step further to the complete automation. For example, if you see the SWE bench, the leaders of the SWE bench on the SWE bench leaderboard, you'll see a lot of the multi-agent frameworks. You'll not see a single completion models being there on the leader bench. So all the top 5 leader bench, you have multi-agent frameworks using either Anthropic models, OpenAI models. Now with the reasoning models coming in, the way to ask question for the reasoning models is something different. So you all have to understand. For the chat models, you should give detailed explanation what it has to do and everything. But for the completion models, you just say, give a very high level instruction, it will reason on its own. So because of this, you can, for coding, for like I say, code maintenance, where the issue would have occurred before, and through the logs, you could figure it out. And from the knowledge base, you know what to fix. All those things will be done with very high accuracy by these reasoning models. In fact, at Vayavya, we are also trying to use this multi-agent frameworks to fix certain MISRA violations and also maintain the code. Particularly we are also working to bring out a benchmark similar to a SWE bench. Now, what is a SWE bench? SWE bench is in Python. Whereas Vayavya, we work in C++ domain. So we are trying to bring out a benchmark similar to SWE bench in C++ domain. And with this, right, and with the reasoning models and multi-agent frameworks, a lot of work can be automated.
Very, very, very interesting. So what are multi-agent systems? If you can explain that to some of our viewers who might not be familiar with the term, Shravan.
Sure, definitely. So LLM model, you ask a question, it replies. Now, you say that you try to ask some different question, the reply would be different. Sometimes for certain questions you ask and give certain information as part of the prompt. Prompt is nothing but a question you ask to the LLM. The answer might be correct, answer might be partially correct. Now, what if two models, now you are telling model which is correct and which is wrong. What if two models are interacting among each other? One is for example, in programming domain, one is a analyzer, another one is a code fixer, okay, or a code generator, let's say. And in fact, the interaction, right, because the prompt and the way this model thinks is something different and way this model is something different. So it generates the code, and other model reviews the code and gives the feedback. And the first model fixes the code. So in this way, it's all about like how our teams also work, right? A programmer writes the code and there is a reviewer who's giving a feedback and you go and fix the patch. So in the same way, this model interaction has improved the performance. For the same reason, the SWE-bench leaderboard, you only have multi-agent frameworks. Here I took an example of two LLMs, but there might be multi-agent, and there's an architecture that many libraries, many companies are coming with the architecture for this, how to interact among the agents. Hierarchical or one-to-one basis, many interactions. And here the chat models are used. And these are the trending now.
So in other words, as I understand, the reasoning model will change the architecture of these models?
Yeah, because most of the reasoning that two models, most of the reasoning steps that comes out based on the interaction between the two models is done by one reasoning model itself. So the complexity among the agent-to-agent interaction is going to decrease. And one reasoning model will do lots of jobs of multi-agent interactions.
Oh, that's very interesting. Yeah, so that certainly gives me an insight, and I'm sure the viewers as well, of the kind of simplicity that is driving in a way. Excellent. So Shravan, as DeepSeek tries to develop more features, more functionality, right? What kinds of challenges that you think that they will face, given that there's already established players in the market, there are industry giants that are already out there? What challenges that they should be thinking about?
Yeah, so okay, smaller companies and bigger companies. So smaller companies are very agile. That's the advantage on them. So they try few concepts, they might fail and try some other thing. Whereas the larger companies, they try to think in different way, how to make money out of it, something on those lines, and how to reach it to the masses. Sometimes while thinking on those lines, they may lose track of experimenting new ideas. Take an example of OpenAI. OpenAI started with it was working on reinforcement learning algorithms. It introduced the PPO, proximal policy optimization, which is now the part of RLHF. Now, for a period of time, has it come up with some new reinforcement learning algorithms to the industry? No. The DeepSeek brought in the GRPO, right? Group Relative Policy Optimization. That really changed how you train the model. So now you can say that OpenAI is now really a giant, whereas DeepSeek is very small and agile. So this is how the comparison I would envision.
Interesting. So actually going back a little deeper further into that, one of the things that we hear about is the way they have thought through training the models, right? They have done a lot of work even on the hardware side, and then there's a lot of hardware work that's needed on the training side. So what impact do you think it will make in particular on AI training? Would we need more specialized AI chips? Would we need more companies like this going backward integration with the AI chips? How do you see the future of hardware emerge, in particular the AI chips?
Yeah, to analyze this, the impact of this kind of AI algorithms on the hardware, to analyze this, we can look at the computer vision models. So the evolution of CNN models, called as computer neural networks, if you analyze the evolution of it, and we can easily understand that starting the computer vision models, identifying the objects, identifying the faces, they were all in software. And then the accuracy was very low. For a period of time, the accuracy increased. Right now, it's at a very high level. And when it increased to a certain stage where it can be applied to many use cases, and it has stabilized in its way of architecture evolution, almost stabilized, right? No one wants to try something new because you already hit that limit of human level limit you're hit. So that when that happens, then the industry tries to see where it can be applied to edge devices. Lot of tasks where there is a memory constraints, there's a latency constraints, there is a power constraints. So when they try to apply on this, particularly with respect to the computer vision models also, when they try to apply, then comes the specialized hardware where they may train on some hardware, but to infer and put it to a real use, you will have a very specialized hardware doing the convolution operations. I'm speaking with respect to the convolution neural networks. So the convolution operations, now it can run very efficiently in terms of milliwatts on some specialized hardware. So similar trend will happen on large language models also. But it has to get stabilized. It has to reach that human level. And it has to see through that, okay, there are certain tasks where, yeah, we have achieved what we want. And now let's put it on some constrained devices, edge devices. So there, definitely, then the companies will chip in to bring in the specialized chips, which will perform very optimized, power efficient mathematical operations, which are related to the LLM.
And then we'll probably get more purpose-built AI specialized chips.
Yeah, definitely.
Yeah, excellent. So Shravan, last question. What are some of the top 3 or 4 innovations? You sort of alluded to them throughout the talk show, but if you were to summarize the top 3 or 4 innovations that DeepSeek really brought in this world, what would they be?
Yeah. So DeepSeek MOE, the DeepSeek MOE architecture had the fine-grained expert segmentation, shared expert isolation. Then another thing they brought it through DeepSeek V2 was multi-head latent attention, which percolated to efficient training and inference. And then they brought in the new RL policy, right, which replaced the RLHF now, which is called as Group Relative Policy Optimization, GRPO. And then to train all of these experts and MOE architecture, they proposed auxiliary loss functions for load balancing, expert balancing, all of the things. And then during training part, they have also introduced a multi-token prediction and FP8 training, FP16 training. All of these technologies, one thing that really caught my attention was in the research paper, they clearly mentioned during all the process of this training, there was a stability. They never have to roll back to the previous checkpoint. That itself is an innovation because that rarely happens when you're trying to train these kind of large models. So you spend money, you're pretty sure that there's a stable training process, and at the end of this cycle, you are going to have a good model.
Right. So Shravan, explain the GRPO thing to our viewers in a little bit more detail.
Yeah. So what happened before was in the large language model, you had reinforcement learning. In the third stage of the LLM development, you had RLHF, reinforcement learning to human feedback. Now it had its own pain points, like you need to create a reward function, then you need to use a reward function. To create even reward function, you need to have a human labeled data to create the reward function. And using the reward function, it criticized the output of the fine-tuned large language model. And then that process of critique and generation and played around, and that improved to a better LLM model. Now with the GRPO, Group Relative Policy Optimization, it replaces the last 2 stages. It was introduced in the DeepSeek math paper by the DeepSeek. So it completely replaces this PPO. It enhances the reasoning capabilities. How is this? Because through the reinforcement learning algorithm, it is through the reward. I will just say how the reward has been generated, but through the reward, it is able to reason on its own and try to say which reason works and which reason doesn't work, the chain of thought. And as it doesn't use any critic model, the cost of, if you're using GRPO, the cost has greatly reduced. Now, if you want in a detail, so let's say that they start with the query, and then they ask to the model, then they get a group of responses. Okay, and within that group, you apply the policy. Okay, the rewards are like here, they did not use only one reward. They use three types of rewards, like accuracy reward, then format rewards. Accuracy means how the final answer, how good it is. Then the format rewards means you ask the LLM model to generate in certain format, whether it really sticks to that format or not. So in this way, they had different types of rewards, and these rewards were feedback to the policy, that GRPO. And then it learned, based on these rewards, it learned the chain of thought, the reasoning tokens. And this is what is a GRPO. This is how powerful is a GRPO.
Oh, wonderful. Wow. So that certainly is very innovative. That certainly is very innovative, Shravan. Excellent. So that brings us to the end of the show, Shravan. Thank you so much for spending time with our viewers on explaining the innovation that DeepSeek has brought in, DeepSeek R1 has brought in, and the challenges that exist for some of the giants, but at the same time, opportunities that exist for many, many smaller companies who were so far out of the innovation cycle now, but they can multiple things that they can do, especially with the cost structure that have gone down. So thank you so much, Shravan. Thank you for your time.
Thanks, Arun. Thanks for having me. It was a beautiful interaction. Hoping to see forward.
Thank you.